Hello everyone. Today I'm gonna talk a bit more about characteristic curves, characteristic solutions. How can we derive a general form of characteristic curves for second order PDEs, linear PDEs, and before going to the general case, I would like to talk a little bit about D'Alembert's solutions for traveling waves. And after that, you're going to solve one example of these and then another example on finding the characteristic curves for the dynamic wave equation. And after that, we will cover the general way of finding the characteristic curves in second order linear PDEs and in general the classification of these PDEs based on these characteristic curves. Okay, so let's get started. So consider a traveling wave in the form of UTT, which is the second gradient of u with respect to time, equals to c square uxx, which is the second gradient of u with respect to x. For x and t belong to minus infinity and infinity times minus infinity and infinity, which is the real numbers. Okay. With the initial condition of ux at time 0 is u naught x, and because this is a second order PDE, we need another initial condition for the first derivative. So I'm gonna write it as du over dt of x and 0, and we will call it u1x. Okay, so this one we call u naught x, and the first derivative we are gonna call u naught x, u1x. So these are the initial condition, and then we have this traveling wave. Okay, so now I want to make a general claim about this equation, this traveling wave equation. And so the claim is, so let me write it this way, claim the general solution of this equation may be written as u x and t. So the general solution of this equals to sum of two functions. One function f x minus ct plus g x plus ct. Okay, so this is a general solution of this equation that we can write it in this way. And so let's see, let's prove this. Like it has a simple proof how we can prove that. We want to prove that this equation is a solution for this one, right? So this is a simple proof, so we want to see whether this equation is gonna satisfy that equation. So what I need to do is I need to just take the derivatives of this solution that is proposed and see whether it's gonna satisfy and give me the original is gonna satisfy the original equation or not. So in order to do that, I'm gonna use chain rule. So from chain rule of differentiation, and this is something you need to remember from your calculus if you don't remember it, but I'm just gonna write it down. So ux, which is the first derivative of u with respect to x, is gonna be what? Is gonna be here. We have it here, so let me just show what I'm gonna do. So I'm gonna just write it from here. So it's gonna be the derivative of f, and then the derivative of, if it is like another function inside it, the derivative of hx inside it, right? So it's gonna be plus that one. So it's gonna be f dot f prime times 1, right? Because x, the coefficient of x is 1 here inside, plus the same thing for g, so it's going to be g prime times 1. So this is the first derivative of u with respect to x, and then the second derivative, we can also find it, so it's going to be partial u over partial x square equals to, so from this equation, from the above equation, I'm gonna write it down as f second prime double prime plus g double prime. And then I want to find, so this is the first part of the equation in this equation that I have. So we have just found this part. And now I want to find the second derivative of u with respect to time. So let's do it. So the first derivative of u with respect to time is going to be partial u partial t equals to f prime times, and now I have instead of this I have h, I have to write it as a function of time, h of t, which is minus ct. So then I have to multiply it by h prime, which is gonna be minus c plus g prime times c, right? So this is the first derivative, and then the second derivative of u with respect to time is gonna be d square u over partial t square equals to, so it's gonna be f prime times minus c square plus g double prime times c square, and this is gonna be c square f double prime plus g double prime. Okay, so now I have these two, and I want to combine these two together. I want to have this equation and this equation. So let's see. So as you see, utt equals to c square f double prime plus g double prime, and this equals to, if you look at the other equation, is just uxx, right? So I can just write it c square uxx. So as you see, this will give me the original equation that we had. So this is just giving me this equation, right? So this is giving me ut. So this is actually a correct solution. So this is a solution. So this is giving me c squared uxx, and so this is a solution for this fx minus ct plus gx plus ct. We have proved that it is a solution for these equations, utt equals to c squared uxx, because when you take the derivatives, you get to the same equation. Okay. So this is a proof of this claim, and therefore we can say, so thus ux and t, so this ux and t equal to f x minus ct plus g x plus ct is, this is the D'Alembert equation or D'Alembert solution. D'Alembert's solution for a, so this has two parts, right? So one is a right going wave fx minus ct and a left going wave gx plus ct. So one of these is going to the left and one is going to the right, and I'm going to show it, but just note this is the D'Alembert solution. Okay, so this is the D'Alembert solution for a right going wave and a left going wave, and general solution for this PDE, which is the second the traveling wave equation. Okay, so let's see what does this mean. So if you have, let's say, I'm just gonna draw one of them. If you have, this is x, so let's see, if you have a fx, something like this, say at t equals to 0, so this is f and fx at t equals to 0. Okay, at the initial condition, if you have this fx, then after a while what you get is this, and this is at time t1, so fx minus ct and t equals to t1. So this is just a right traveling wave, right? Because at t1, then you are gonna get the same function as that, fx, but it's just traveled in time into the right direction. Okay, so it's one right going wave and one is left going wave. So this is how it looks like. And now I'm gonna solve an example so you get more familiar with what does this mean. Okay, and so let's get one example. How can we solve this in general form? So say you have a again an equation, the same equation, utt equals to c square uxx, and we want to solve for the following initial condition. So the initial condition that we have is u naught or u0 at x is 1 minus absolute of x when the absolute of x is less than or equal to 1, and 0 when it is greater than 1. And the first gradient or the first derivative of u with respect to time, which is the second initial condition for me, or u1, is 0. So u1x is 0, right? So this is just a simple initial condition. So now let's find the solution of this. What is going to be the solution of it? So the D'Alembert's solution says that we can write the solution as this: ux and t equals to fx minus ct plus gx plus ct, right? So this is what we proved from D'Alembert. And now I want to apply the initial condition to this to find the exact form and formula of f and g functions. So I want to find what are these two functions, okay? So the first one is u at x and 0, which is u0x, which is that function. So I'm not gonna write the exact function. I'm just gonna write this as u0x, and this equals to fx plus gx. Okay, so this is what the first initial condition is gonna give me, and I'm gonna write it as equation 1. So let's see what is gonna the second initial condition give me. So we have du dt at x and 0 equals to, so what is the first derivative of u with respect to time? Well, I can just write it from here. I just need to take the derivative with respect to time. So it's gonna be minus c times f prime, and it is at time 0, so it's gonna be x plus c g g prime x, and this equals to u1x, which in the problem statement it is set to 0. Okay, so this is the second equation, but I want to further simplify this. So the c's on both sides are gonna cancel out. So as you see, they are gonna cancel out because it's equals to 0. So I'm just gonna have f prime x equals to g prime x, and now I'm gonna take the integral with respect to x from both sides. So I have 0x f prime x and say dk c. So take the integral with respect to x, and this is gonna be equal to what? It's gonna be equal to fx from x to 0, which is fx minus f0. The same thing for g. I'm gonna take the integral, and this is gonna give me gx minus g0. And so I can just write down because f prime x equals to g prime x, I can just write down fx minus f0 equals to gx minus g0. Okay, so this is the second equation that we can find from the initial condition. And now what I'm gonna do is substitute one in two. So I'm gonna get fx to find fx. Fx equals to, so let's see what we have. Fx equals to, we have the first term is f0 minus g0, right? Plus and instead of now we have instead of gx, I'm just gonna write u naught minus fx. So I'm just gonna get u naught x minus fx, right? So this is the equation I'm gonna get. And so I can bring the fx from right hand side to the left hand side, and I'm gonna have 2fx. So it's gonna be fx equals to u naught x plus f0 minus g0 over 2, right? And gx is gonna be similarly found as u0x and minus f0 minus g0 over 2. Okay, so now in f, this is just a notation, right? So I just changed the name. So in f, just replace x by x minus ct, and in g, replace x by x plus ct. So then what we are gonna have is this. So we are gonna have fx minus ct equals to u naught x minus ct plus f0 minus g0 over 2, and gx plus ct equals to u naught x plus ct plus minus f0 minus g0 over 2. Okay, so now we have these we found these functions. What are fx minus ct and gx minus ct, right? So based on the D'Alembert's equation, which was saying ux and t equals to fx minus ct plus gx plus ct, I can just combine these two equations, and what I'm gonna get is u naught x minus ct plus u naught x plus ct over 2. And these two are going to cancel out. Right? When you sum them, these two equations, these two have a negative, this one has a negative sign, this has a positive sign, so they are gonna cancel out. So this is gonna be my final solution for this problem based on the initial condition that was given. Okay, this is how you can approach these kind of PDEs and solve the equations. So now I want to plot these solutions so you get a better insight and understanding of how these solution looks like. Okay, so first let's get started by just doing it one case, and then I'm gonna do a more general one. Okay, so here is x, here is t. And so at x t equals to 0, the initial condition gives me this function, which is 1 minus absolute of x when x absolute of x is less than or equal to 1, and 0 when it is greater than 1. Okay, so this is a simple function. I can just draw it. So it's gonna be something like this, where here is 1, here is 1, and here is minus 1. So this is gonna be the function at t equals to 0. So now the question is, what happens as t increases? Okay, so as t increases, we have two traveling waves. One is going to the right, and one is going to the left. Okay, so now I want to show what happens, say, at higher t's, okay, at higher time. So you see here from this equation that we have two solutions, right? So here, let's talk about somewhere like very far from this location. So here we have this. So here what you are gonna get is a superposition of two waves. One is going to the right, so this is gonna be u naught x minus ct over 2, and this is gonna be u naught over 2, and this is gonna be u naught x plus ct over 2. Okay, so it is just here at the beginning we had these two waves that superimpose together and then constitute that, so we need to divide it by 2 and then just plot it here. So I'm gonna just plot it here, so divide it by 2. and this is gonna be my solution here. So one is going this way and one is going that way, to the left and to the right. Okay, so just to give you, this is gonna be 0.5, right? So this is 1 and this is 0.5, and the same thing here, this is gonna be 0.5. And so we have two waves, that one is going to the right and one is going to the left, right? So at any t, you can find these just by these two characteristic curves, right? X minus ct and x plus ct. So what actually this does is, sorry for that. So what it actually does is, let me add one more page. So what it actually does is the initial condition just give me a second to fix this.